In this lesson, we'll go over the sum and difference formulas for sine, cosine, and tangent. So to start with, what is sine of 30 degrees, 45 degrees, and 60 degrees? These were three angles that we know sine and cosine for. So over here on the unit circle, maybe this is a 30-degree angle. So it's like 30 degrees. And we know sine at this is exactly equal to a half. A 45-degree angle, so that's maybe right about here. This is 45 degrees. Sine here is equal to root 2 over 2. And then a 60-degree angle, that's roughly something like this. Here's 60 degrees, great. And sine of 60 was root 3 over 2. So these were three exact values for three different angles that we know. But what if we had an angle that wasn't one of those three? Like, let's say 75 degrees. What is sine of 75 degrees? Well, first of all, 75 degrees, it's also in the first quadrant. So, maybe it's like roughly about here. So we don't currently know an exact value for sine at this angle. Is it possible to somehow use these other angles to help us figure out the value here? One observation to make is that, well, 75 degrees itself is actually the sum of 30 degrees and 45 degrees. So you could say, well, I don't know what sine at this angle is, but I do know that 75 is the sum of 30 and 45 degrees. From here, it's like, well, I don't know, what could you do? Could you do anything? I mean, maybe you could think, hey, is it possible that, well, maybe I can say this is equal to sine of 30 degrees plus sine of 45 degrees. Maybe I can just break it apart as a sum like this. Is this possible? I'm just going to check to see if this works in the calculator. Does sine of 75 degrees equal the sum of these two things? Well, sine of 75, let's see, this is about, okay, that's like 0.97 if I round to two places. Sine of 30 degrees is a half, so I know that's 0.50. And then sine of 45 degrees is about 0.71. Okay, yeah, these two things aren't equal. If I add these two numbers together, it's not going to be equal to this number here. So unfortunately, you can't do this. Like, that's no good. You can't just break it apart. Oh, I have two angles. Maybe I can break it apart into the sum of those two things. This isn't true. However, there actually is a formula that tells you what to do if you're adding two angles within the sine function, and we call this a sum formula for sine. On the next slide, I'm going to state what the formula is, and we will use it to compute sine of 75 degrees exactly. To start with, let's actually write down the formula for sine of an angle alpha plus another angle beta. The formula is this. It is sine of the first angle alpha times cosine of the second angle beta, and then you add on to that cosine of the first angle alpha times sine of the second angle beta. So the pattern is it goes sine, cosine, then it goes cosine, sine, but we keep the angles alpha and beta in the same order. So here's a formula. This is called the sum formula for sine. Let's use this formula to actually figure out what the exact value of sine of 75 degrees is equal to. So for starters, we already noted that, well, sine of 75 degrees is the same thing as sine of 30 degrees plus 45 degrees. So if you want to apply this formula, you got to break it up into the sum of two angles. So for my formula, alpha is acting as 30 degrees, and beta is acting as 45 degrees. That being said, according to this formula, the answer is the same thing as sine of 30 degrees times cosine of 45 degrees plus cosine of 30 degrees times sine of 45 degrees. I don't know the exact value of this, but we broke it up into two angles that we know the values of sine and cosine for. So the rest is just plugging in something we already know. sine of 30 degrees is equal to a half. Cosine of 45 degrees is root 2 over 2. I'll add on, okay, cosine of 30 degrees, that is root 3 over 2, and sine of 45 degrees is root 2 over 2. And this thing is kind of a mess, but this is a value. This is an exact value. I say we, simplify it a little bit more. For starters, I can multiply the fractions together, which will give us a common denominator. So let's see, we get root 2 over 4 plus root 3 times root 2 over 4. I can add these two fractions together because they have a common denominator. I'll put that over here. So this is root 2 plus root 3 times root 2 all over 1 fraction 4. And I can put this into one square root. The square root of 3 times the square root of 2 is the square root of 6. And so I get this answer of root 2 plus root 6 all over 4. This is definitely not a value that you should memorize sine for of 75 degrees. What is important here is that you can use this formula to actually figure out an exact value instead of having a decimal. In example 2, we're going to do something different. We're going to try to figure out, well, what is the exact value of sine of 15 degrees? The thing to note here is that 15 degrees is the same thing as sine of, okay, this is 45 degrees, not plus, but minus 30 degrees. 45 degrees and 30 degrees is something that we know sine for. And if we take the difference of those two angles, you get 15 degrees. Unfortunately, up here, I see that there's a plus sign, and in here there is a minus sign. There's a simple way to make an adjustment in this formula so we can apply it here. If you are subtracting the two angles, alpha and beta, then you simply subtract over here. So if you see a plus sign, it'll be a plus sign on this side of the formula. If you see a minus sign, it'll be a minus sign on this side of the formula. So if we want to compute this exact value, we can break up 15 into 45 minus 30. I can now go to this formula to get the final answer. All right, so here we have that alpha is equal to 45 degrees and beta is equal to 30 degrees. This becomes sine of 45 degrees times cosine of 30 degrees minus cosine of 45 degrees times sine of 30 degrees. That's it. From here, it's a matter of, do I know the exact values of these four pieces, and can we simplify that? Well, sine of 45 degrees is root 2 over 2, and cosine of 30 degrees is root 3 over 2. I'll subtract cosine of 45 degrees, which is root 2 over 2, and then sine of 30 degrees, which is a half. Just like in the last problem, I know we're going to have a common denominator of 4 and 4, so I'm just going to jump right to a single fraction and put 4 in the denominator. I'll multiply these two things to get this part here, and I'll subtract off the product of these two, which I'll put here. So this is going to be root 2 times root 3 minus root 2 times 1. I can simplify this to root 6 minus root 2 all over 4, and this is my final answer for the problem. So here we had a slight variation in the formula. For this formula, if you see a minus sign, that just means there'll be a minus sign on this side instead of a plus sign. So there isn't just a formula for sine, but there is one for cosine, and there is also one for tangent. But next, I'd like to just simply state what the formula is for cosine of the sum or difference of two angles. So like if you are adding or subtracting two angles, what do you do over here? It was nice for sine because if you add, then you add here. If you subtract, then you subtract here. The thing about cosine is it's actually the opposite. if you add over here, then you actually subtract over here. And if you subtract over here, then you actually add over here. And this is reflected in the formula by putting a minus plus instead of a plus minus. So the cosine here is going to be cosine cosine. Then we switch the sign and end with sine and sine. That being said, can we find the exact value of cosine of 15 degrees using one of these formulas? Well, clearly I want to use this one here. So I'm going to have to write this as cosine of a sum or a difference. And as we've already seen, well, to get 15 degrees, we can use 45 degrees and subtract off 30 degrees. This gives us our alpha and our beta. Now, if I just refer to the formula, here's what we get. For the formula for cosine, it starts with cosine of alpha times cosine of beta, and then this time we're going to add, and then it's going to be sine of alpha and sine of beta. We now have four things that we know the exact values for. Cosine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. I would add on, sine of 45 degrees is root 2 over 2. And sine of 30 degrees is a half. So for the first two fractions, if I multiply them, I get root 6 over 4. And for the other two fractions, I get root 2 over 4. There is a common denominator, so I can add these together. I get root 6 plus root 2 all over 4, and this is the exact value for cosine of 15 degrees. In example 3, I want to find the exact values for either sine or cosine of a given angle. And here we have 195 degrees. I think the hard part of this question is going to be, well, how do I split up the 195 degrees into two angles? I think a good strategy is to think about the angles of 30 degrees, 45 degrees, and 60 degrees. They're probably going to play a role in some way. So I guess for starters, you could say, well, if I had 195 degrees and I took away 30 degrees, will I end up with an angle that I already know something about? So, I got my calculator here, I'm subtracting 30, and I get 165 degrees, and, that really doesn't seem helpful. That didn't really seem to take me anywhere. What about this other one? What if I, took 195 degrees and I subtracted 45 degrees? If I take the difference here, I get 150 degrees. I think that the angle of 45 degrees and 150 will actually be helpful in figuring out cosine of 195 degrees. Here's why. Here is a 45-degree angle. It's in the first quadrant. And I know both sine and cosine for this angle. That's perfect. Where is 150 degrees? Well, that is in the second quadrant. It's roughly here. In fact, it is 30 degrees back from 180 degrees. That means 30 degrees is a reference angle for 150. You can think of 30 degrees over here. Oh, this is great. Because 150 has a nice reference angle, in fact, it refers back to 30 degrees, I think these are the two angles I want to use to split up 195 degrees. So I'm going to take cosine of 195 degrees, and I'm going to write that as, well, that's really cosine of 45 degrees plus 150 degrees. I'm now going to use the sum difference formula for cosine. Okay, the way that worked is, it's going to be cosine of 45 times cosine of 150 degrees. Okay, I see a plus here, so I actually want to switch to a minus, and then I'm going to have minus sine of 45 degrees and sine of 150 degrees. All right, excellent. I took 195, I split it up into these two angles. I then applied the sum difference formula for cosine, The rest is, do I know the 4 exact values for cosine and sine at these angles? Well, cosine of 45 degrees is root 2 over 2. Okay, but now I come to cosine of 150 degrees. This is either equal to cosine of 30 degrees or the negative of the value at 30 degrees. Since 150 degrees is in the second quadrant, cosine is negative there. So cosine of 150 degrees is actually equal to, I'll put parentheses, it's the negative of cosine of 30 degrees. Cosine of 30 degrees is root 3 over 2. So cosine of 150 is negative root 3 over 2. I then subtract off. Okay, sine of 45 degrees, that's root 2 over 2. And sine of 150 degrees, okay, that is either equal to sine of 30 degrees or it is the negative of sine of 30 degrees. Because sine is positive in the second quadrant, it's actually equal to the positive value of sine of 30 degrees, which is a half. What does all this mean? We have the answer, it just has to be simplified. Here, it's going to be negative. If I multiply the fractions, the denominators give me 4, and the numerator gives me the root of 6. I then subtract off, and if I multiply these two fractions together, I get root 2 for the numerator, and then 4 for the denominator. Let's combine this into one fraction. You can actually remove a negative from both terms in the numerator. The denominator is 4, and the numerator is root 6 plus root 2. Here, this negative would distribute to both of these terms, making both pieces negative. This is my simplified final answer. Let's find the exact value of sine of 7 pi over 12. So here we have something that is in radians, and I want to somehow break this up into two angles that will be helpful for us. So the angles that are useful, just to write those out here, 30 degrees, 45 degrees, and 60 degrees, their equivalent forms in radians are pi over 6, pi over 4, and pi over 3. So here I want to use these angles, not something in degrees. So how can I get to something, with a 12 in the denominator looking at these three fractions here? Well, I see that if I were to add pi over 4 and pi over 3, I would get a least common denominator of 12. So maybe that will work. So I'm just making a guess here. Could it be that if I add pi over 4 and pi over 3, I would get something, well, hopefully 7 pi over 12. So like I said, we need a least common denominator. So I'll multiply this by 3 over 3. I'll multiply this by 4 over 4. And yeah, this is going to work out well. We have 3 pi over 12 plus 4 pi over 12, which is equivalent to 7 pi over 12. This is great. I want to split this up into pi over 4 plus pi over 3. So let's do that as our first step. Okay, now that I have broken it up into two angles, I can use the sum difference formula for sine. And the way that went was, it's sine of the first angle and then cosine of the second angle. I add cosine of the first angle and then sine of the second angle. So I know sine and cosine for these two angles. Oh, see, I made a mistake. That should have been a 4 in the denominator. So the angles always alternate. It's the first one second, the first one the second one, and then it goes sine, cosine, cosine, sine. So the exact values for sine and cosine, for pi over 3, that's going to be root 3 over 2. Cosine of pi over 4 is root 2 over 2. I'll add on, cosine of pi over 3 is a half, and sine of pi over 4 is root 2 over 2. If I multiply the fractions together, I get root 6 over 4 plus root 2 over 4. I have a common denominator. So this is root 6 plus root 2 all over 4, and that is my final answer. So what about for tangent? What's the formula for tangent? Because tangent of, any angle theta is defined as the ratio of sine to cosine, you could do sine and cosine individually, divide the two numbers, and that would be the value for tangent. But there's a formula for tangent itself, and that's what I'm going to write down next. So the tangent formula goes like this. It's tangent of alpha plus or minus tangent of beta divided by 1, and I'll put minus plus tangent of alpha times tangent of beta. So this is the formula that we will use. So a couple things to note. If you're adding, this part here means, well, you would put a plus sign here. But this minus plus down here means, well, if this was addition, then this should be subtraction. Likewise, if you start with a minus, it'll be a minus here. But down here, you'd use the plus sign. Okay, let's use this formula to simplify tangent of negative pi over 12. So this is in radians, and you want to hopefully use, either pi over 3, pi over 4, pi over 6 to break this up into a sum or difference from angles over here. So if you want a denominator of 12, I think we could use these first two fractions here. And I want the answer to be negative. I think I'm going to have to subtract. And I want to subtract a larger number from a smaller number. So if this is going to work out nicely, it would have to be something like, I guess, maybe it's pi over 4 minus pi over 3. This is larger than this, so it would subtract to give me a negative number. The least common denominator is going to be 12. Let's see if this works. We get 3 pi over 12 minus 4 pi over 12. And yeah, this works. When you subtract the numerators, 3 minus 4 with the pi's would leave you with a negative pi. And you can just put that negative in front of the whole fraction. So here's how you can split this up into pi over 4 minus pi over 3. So this is equivalent to computing tangent of pi over 4 minus pi over 3. All right, I can now go to this formula to get my answer. Let's see. Well, first of all, it's a negative, so I know it'll be negative then positive. So let's write out what we get. Put that down here. This is tangent of pi over 4 minus tangent of pi over 3. That whole thing divided by 1 plus tangent of pi over 4 times tangent of pi over 3. So from here, I just have to know the exact values for tangent at these two given angles. I know tangent of pi over 4, that's equal to 1. And I know tangent of pi over 3 is equal to the square root of 3. So I'm going to, plug all those things in and see what we get. So that's going to be 1 minus root 3 all over 1 plus. Okay, this is 1. This is root 3. I'll just put root 3 because that's the product of those two things. So here is an exact value. Typically, you wouldn't want to leave the denominator with a square root like this. You can actually simplify this a little bit further. The trick to doing this is you multiply the denominator by its conjugate, which is 1 minus root 3. So this plus, you switch to a negative, and if you multiply this to this, it'll cancel all of the square roots. But you want to make sure you also put the same thing in the numerator so you're not actually changing the value of the fraction, so I'll put 1 minus root 3 up here. So I'm going to take this extra step of, well, let's simplify this by getting rid of the irrational number in the denominator. If I multiply the numerator, I get 1. I get minus root 3. That came from multiplying this 1 here and this 1 here. I then distribute in the negative root 3, so I get another negative root 3. And then negative is positive. Root 3 times root 3 is actually 3, so positive 3. This is all divided by, I'll do the same procedure in the denominator. I have 1 times 1, that's 1. Okay, I get a negative root 3, but I also get a positive root 3 when I multiply this here. This is why this trick of multiplying by the conjugate works. It'll actually cancel the roots from the denominator. I also get positive root 3 times negative root 3, and so that's negative 3. Okay, if I start simplifying all of this, my numerator is, well, what do we have here? We have 1 and 3. That adds to 4. And I have minus 2 root 3. In the denominator, those cancel, and I have 1 minus 3. That's negative 2. We can actually break this up into two separate fractions. Negative 2 divided into this 4 is actually equal to negative 2. And this negative 2 divided into this negative 2 cancels to give you a positive 1, which I won't write, but I'll just put the root 3. So this would be the completely simplified version of this answer here. And that's it for this problem.